In general, we can simply add two disjoint probabilities. If we want to know the probability that the card we're drawing is a jack or that it's a queen, we can simply add the probabilities that they are a jack to the probability that they are a queen. This is covered extensively in the book chapter. However, we are not always able to just add things if they are not disjoint. That is, what happens when there is some overlap. As an example, what is the probability of drawing a king or a one-eyed royal? For those of you unfamiliar with royal cards in poker, or a general deck of cards, there are 12 cards among the royals. 4 jacks, 4 queens, and 4 kings. As I mentioned before, if we want to know the probability of a jack or a queen, we could simply add those together. However, there are a limited number of one-eyed royals, including 2 jacks, note only 1 eye instead of 2, and 1 of the kings. Because of that overlap, we can't simply add these together. Instead, we need to subtract that overlap to avoid counting it twice. So out of these 12 cards, and the 52 cards in a deck in total, we are actually only going to have 1, 2, 3, 4, 5, 6 that are going to match either a king or a one-eyed royal. If we counted this king a second time for the one-eyed royal, we would have too many, and our calculation would be incorrect. In mathematical notation, we write this as the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both A and B. So in the case of our card example, we have the probability of being a king or a one-eyed royal is equal to the probability of being a king plus the probability of being a one-eyed royal minus the probability of a one-eyed royal. Putting numbers in here, our probability of being a king is 1 in 13, or 4 in 52 for the whole deck. Our probability of being a one-eyed royal is 3 in 52. There is one one-eyed king, so we subtract that, leaving us with a total of 6 out of 52. Note here that this probability of being A and B becomes 0 when there is a disjoint probability. That is, if there is something where you can only be one or the other, you can never be both. You could not be both a jack and a queen, for example.